Hey, math friends. So our learning target today is that I can review Unit 4 on slope-intercept form and POI, which means point of intersection. So we're going to review the entire unit of Unit 4. So the first learning target, I can write an equation of a line in slope-intercept form, y equals mx plus b. This should be familiar to you. That is our first learning target here. So first thing I need to do is I need to calculate the slope. So I'm going to use that triangle or that rectangle method, which I've shown you a few times, but you can use any other strategy of like the hotel analogy or anything. We have a negative slope here because the line is decreasing, gas coming out of tank. 1, 2, 3, 4 units high, 2 units wide. So my rise is -4. My run is 2, which is the same as -2 over 1 or just -2. The y-intercept is the place where the graph crosses the y-axis. So we're going to go back and grab that y-intercept. Actually, in the future, I might grab that first, just so I don't have to erase so much. But the y-axis is here. Here's my y-axis. And the place where they intersect or intercept is right here, this coordinate. And the b value then is the y coordinate where the intersection occurs, so -1. So my equation then is y equals -2x minus 1. And of course, you can always write that as -2 over 1. All right, next problem, same plan. I'm going to grab the y-intercept first. So here's my y-axis. Here's the y-intercept. It's at -4. Then I won't have to erase. And then the slope. I'm going to use that same method here. I'm going to grab these two. Now let's check out the scale. Make sure we're scaling by 1. This is -3, so yes, we're scaling by 1 unit high. And then make sure that we're scaling by 1 here as well. Yeah, so 2 units wide. So it looks like the rise is positive 1 over 2. I'm going to confirm that. 1, 2, 1, 2. So my equation then is y equals 1/2 x minus 4. 1/2 x minus 4. Check it out. Boom. For the next problem there, be careful with that one because it is a flat horizontal line. What does that mean about the change that is happening or the gas going in the tank or coming out of the tank? Here's my y-axis and my x-axis. So we're really talking about the red line. And the red line intersects right here at -1, -2, -3. It's looking like the y-intercept is, the coordinate there is 0, -3. But the y-intercept is just the y coordinates. I'm having a hard time writing that, -3. The slope here is 0. No change happening. Not scary, no change. So we get y equals 0, x minus 3. Mathematically speaking, we know that this just crashes to a 0. So we go y equals -3 as our final answer. That is the equation of that line. 0 times any x value is going to be 0. So that 0 kind of drops off there. All right, let's take a peek at question 4. Tricky, tricky, tricky. Here's our y-axis. Cool, 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 cool. Where do the red and blue line intersect? So we can find that y-intercept. Where do they intersect? They don't. Wait a minute. So this y-intercept is like what? Question mark. I don't get it. It's not available. It's not available. They never do intersect. The slope of this line, what would happen if we ski down this hill? We would die. So we've talked about that is undefined. So how do I write an equation in the form of y equals mx plus b when I have a word to put in for slope and I have a question mark to put in for y-intercept? Well, let's just talk about what we do know are the patterns on this graph. So we know that right here, this is the x value of 2, the y value of 0, that coordinate right there. Let's take a coordinate down here. That's the x value of 2, the y value of -1, 2, 3, 4. Okay, and let's grab a different one like up here. That's the x value of 2 and the y value of +1, 2, 3, 4. So what is true about everything on that line? What is true is that all the x's are 2 everywhere. The y's are changing, but all the x's are 2. So the conclusion we can say, or the pattern, is that we know all the x's on that line are 2. that would be our best equation that we could come up with, given that the slope is undefined and the y-intercept doesn't exist. All right, next problem. Here we go. Number 5. The y-intercept looks to be at 0, because here's my y-axis. Here's my x-axis. Yep, looking to be at 0. Okay. My slope then, I'm going to try to find 2 nice data points. Well, the origin looks good, 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 good. I'm liking that. Searching, searching. Nope, nope. Yep, maybe this one. So if we build that rectangle then, we get a rise, or the height of the rectangle is 1. The width of the rectangle is 3. So this is a decreasing line with a slope of negative 1/3. So my equation then is y equals negative 1/3 x. Y equals negative 1/3 x. All right, next problem. Question 6. So we're given this equation. The y-intercept is what I'm going to start with. So it's where the y-axis hits the data point, which is right here. So at 249, the y value there. I do not like the slope there. So I'm going to build a table instead. That slope is nasty. So we have a 0, 249. And we have a 392. All right, so I'm going to build it through subtract the y's, subtract the x's. It's the same as rise over run, but boy, that rise and run is ugly. So 249 minus 392 gives me negative 143. Okay. The other one I can handle. 0 minus 50 is negative 50. So check, check, check it out. Can we reduce? Because in slope, we have to reduce. A negative divided by negative is really a positive. And can we reduce? I'm not seeing anything. So I'm going to leave it as 143 over 50. You could put it in a decimal form, but I'm just not going to. Y equals 143 over 50. We're talking millions of people per year. All right, x, this is a 50, plus 249. So the slope was 143 over 50, x plus 249. Cool, cool, cool. So that's your first learning target, writing in the form of y equals mx plus b. Now we saw some crazy things going on, like what do we do when it's a horizontal flat line? What do we do when it's a vertical line? Make sure you rewind if that's confusing to you. The next learning target is, how do you graph in the form of y equals mx plus b? And I always call this, when I'm teaching live in class, I always call this fast graphing, and I call it the fast graph because it is the fastest way to graph. You could set up a table, but you really don't have to if you're given a slope and a y-intercept. So the slope then is 3 over 1, technically. The y-intercept is 4. B means begin. M means move. So begin at 0, 4, 0, 4. All right, so begin at 0, 4. So that would be 1, 2, 3, 4. Begin there. And then move up 3 over 1. So up 1, 2, 3 over 1. Try that again. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. You can also work it in the other direction if you run out of graph. So it'd be down 1, 2, 3, left 1. Down 1, 2, 3, left 1, and so on. Down 1, 2, 3, left 1. 1, 2, 3, left 1. And that would be our graph then. So this is our graph of our line that we just graphed, which is y equals positive 3x plus 4. That's the graph. That's called fast graphing. All you need is a slope and a y-intercept, and you can crank that out pretty fast. So the y-intercept here is at -5, which really is 0, -5 for just frame of reference. The slope is 2/5. So I'm going to go to 0, -5. 1, 2, 3, 4, and 5, 0, -5. I'm going to rise to, run 1, 2, 3, 4, 5. Rise to 1, 2, 3, 4, 5. Now you can work in the other direction as well. Down to 1, 2, 3, 4, 5. And this is the graph. Y equals 2/5 x minus 5. All right, keep going. Again, all you need is a slope and a y-intercept, and you can crank this out. The y-intercept is at 2, which is really 0, 2 for frame of reference. When there's a negative out front, I would always attach it to the numerator, which is negative 1/3 for the slope. Okay, so here we go. Begin at 0, 2. Run your slope. The rise is negative, so we're going to go. I don't even know where the problem is, to be honest, you guys. Where did it go? Okay, so the rise is negative 1. So we're going to go down 1 over 3. Down 1, right, 1, 2, 3. Down 1, right, 1, 2, 3. Down 1, right, 1, 2, 3. You can also work in the other direction. Go up 1, left, 1, 2, 3. Up 1, left, 1, 2, 3. Up 1, left, 1, 2, 3. So this is the equation y equals negative 1/3 x plus 2. Next problem, still graphing in that same form. The y-intercept here is actually at 0. And this slope represents really negative 3 over 1. So we're going to start at the origin. And we're going to go down 3, down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. And then the opposite direction, up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So this line here is y equals negative 3x. That's our learning target on what we call fast graphing. All right, keep going. We're at 11-minute mark. Now remember, this is a review of the entire unit, so I'm covering everything for the unit. This learning target says that we're going to find the point of intersection, so where it crosses, where the two lines cross. For graph, table, and equation, we want the same answer in all three of those, proving it. All right, so by table, by graph, I'm actually going to cheat my way through it a little bit and go right down to equations. So I'm actually going to move this real quick. Cheater, cheater, cheater. Ah! And I'm going to do equation first because why not use algebra right away in the algebra course? Point of intersection then. So POI, point of intersection, we're just looking for where these two lines cross, where this line hits this line. And since they're both y, we can set this quantity equal to that quantity, which is super fun. So we're going to set the two y's equal to each other because y means y equals y. So set the quantities equal to each other. Now, in this situation, we know there's a coefficient of 1 here. We're going to take the smallest variable term first and move it, which is this one. So when we move it, we add opposite or inverse. All right. So as we solve then, we end up with 4x minus 3 is equal to 5. Build house, build fence, or hand method kicks in. We're going to go opposite or inverse here. We're going to add 3, copy, paste, boom. If I haven't used it, drag it down, drag it down. So what we're going to do now is we're going to divide both sides by 4. Do it, do it, do it, do it. We get x equals 2. So we believe that the point of intersection has an x value of 2. So we think x is 2. But what's y? So we plug it back into both equations. So I'm going to steal this again. I'm going to move this around a little bit. Again, you need to pause. Do it. It's normal to pause when you're watching a video. When you're live in a class, you obviously can't. So that's 3 times 2 minus 3. And that's negative 2 plus 5. And we want to make sure that both of these equal the same answer. So this would be 6 minus 3 is 3. Well, that's the output. And we solve this, we get 3. So we know that either way, our y value is 3. Cool. Point of intersection is 3. So then we graph these. Right 2 up 3 should be right 2 up 3 should be our point of intersection when we're done. That would be our goal, that we believe the point of intersection should be 2, 3. So we're going to set up our tables here. And in the table, we believe that the point of intersection should be 2, 3. It should follow the pattern. So let's go ahead and take a peek to see what happens. I'm going to have to grab those equations wherever I put them. pull them back up into the madness here. So what we're trying to do is prove that the table graph equation has the same answers, that the POI is the same. If you think this looks easy, you're wrong. This is not moving for me very well, and that's frustrating. Okay, so here we go. Here's the two equations. We've already decided that the POI is 2, 3, but the learning target says you have to prove it in the table, the graph, and the equation. So I'm going to pick some values. I'm going to start some -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. I'm going to put 3x minus 3 on this side, and I'm going to put -x plus 5 on that side. Ooh, we could fast graph those too. Maybe we should do that. All right, so we have -2. When we plug in -2, we get -6 minus 3 is -9. We plug in -1. 3 times -1 is -3. Minus 3 is -6. You are welcome to use a calculator if you need to do that. Just push pause too and just do the whole table and then push play to see if you got it right. But I'm going to keep trucking away here. 3 times 0 is 0. Minus 3 is -3. Maybe you can recognize a pattern here in the table as well. We plug in 1. 3 times 1 is 3. Minus 3 is 0. And then we have the 2, 3 already calculated for us, but let's confirm. 3 times 2 is 6. Minus 3 is 3. Cool. Likewise, on the other side, we substitute in negative, ooh, be careful there, -2. -2 is +2 plus 5 is 7. Do the same thing with that. -1 plus 5 is 6. Plug 0 in is 5. Plug 1 in. -1 plus 5 is 4. Plug 2 in. -2 plus 5. And we can confirm that we believe that the point of intersection in the table is also 2, 3. That x is 2, y is 3 in the intersection of these two. I'm going to fast graph these because why not? We just learned how to do that. I'm going to start at -3. And my slope here is 3, which means really 3 over 1. So I'm going to rise 3, 1, 2, 3 over 1. Rise 1, 2, 3 over 1. Ooh, I like that. Rise 1, 2, 3 over 1. Very exciting. This is the equation here of y equals 3x minus 3. Isn't it so fun that we can learn how to fast graph? I know. I agree with you. All right, fast graphing this one, we start up at 0, 5. This is, remember, like 0, 5. Cool, cool, cool. So we go 1, 2, 3, 4, 5. I love it. I love it. I love it. Now this right here really means like -1x, right? So that's really -1 over 1 for the slope. So we're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Cool. And we can confirm, check it out, that the graph also got that POI that we were hoping for right here at 2, 3. So we got the POI in the table, in the graph, and in the equation. 2, 3, 2, 3, point of intersection of those two equations. Check it out. All right, cool. So now the learning target is just going to be what we did on that last step of how do we find a point of intersection of two equations. Just the equations. We don't have to do the table and the graph. All right. Love, love, love it. So we're going to set the two y's equal to each other since y does equal y. So we get 6 minus 2x is equal to 3 times the quantity of 2x plus 4. Write it, write it, write it, write it, write it. Just pause if you need more time. You got this. Come on. All right. Nothing to solve on the left, but on the right-hand side, we have distributive property. Cool. Kill that parenthesis. I feel like we've solved this problem before, actually. Smallest variable term is right here. That was a minus. So we're going to add 2x, copy, paste. I probably should have written smaller here because I'm running out of room. So we get 6 is equal to 8x plus 12. Cool. Cool, cool, cool. Next step is to subtract 12. Copy, paste, copy, paste. So we get -6 is equal to 8x. Divide both sides by 8. And we get x equals, this becomes -3/4, which we can say is -0.75. Ooh, I might have forgot to plug it back in that video I made, but that's okay. All right, so I have to erase this just so I can write. So the point of intersection so far is we believe that the x value is negative 0.75. I'm also going to erase all of this work. You can just rewind because I need some room to check my y value. All right, so for my y value, then I'm going to plug it back into both of these equations to make sure that it works. All right, here we go. So we have y equals 6 minus 2 times negative 0.75, and y equals 3 times 2 times negative 0.75 plus 4 in a big parenthesis. All right. When I plug in the top one, 6 minus 2 times negative 0.75, the output of this gives me 7.5. Checking the bottom one. Maybe I did do that actually. So we have 3 times 2 times negative 0.75. Oh my gosh, this is a mess. I need another parenthesis or something. Oh, yes, I do. Negative 0.75. I am sorry, I missed a parenthesis here. Plus 4, then a parenthesis, and I did get 7.5. Coolio. So we know that the x value is, when we plug it in, we know that it must be right because either equation, when I plug it in, I end up getting 7.5 for the y value. So here's my x, here's my y. That means that's where those two lines would intersect when we graphed. That would be an ugly graph intersection, so better that we're just working with the equations. All right, same plan. Set them equal to each other. Set the two y's equal to each other. Cool. If you like it, give it a big heart when you're done. If it's just okay, box it in. All right, here we go. Let's kill some parentheses, eh? This is going to have to wait because it's on the outside and it's a 3 subtract 5. It's just going to have to wait. Distribute. Keep in mind we have a lonely 1 sitting there. So we have negative 5x. Cool. Distribute. Positive 20. Equals. I'm going to pull that 3 back in the game right away so I don't forget. On the right-hand side, distribute is 16x. Distribute negative 40. Cool. Combine like terms then. So 3 plus 20. When we combine those, we get 23 minus 5x equals 16x minus 40. All right. So with that said, we have a multi-step equation here with a variable on both sides. Smallest variable goes. So we're going to add 5x to both sides. All right, there we go. Just having a hard time pushing that button. Looking for the point of intersection here. All right, cool. Where's the pen? I don't know what's going on. Why are you doing that to me? Okay, drag this down. I don't even know what that says now, you guys. That's 23. So 23 equals 21x minus 40. It's pretty bad when you can't read your own writing. Right? Clean up 4x here. Let's isolate. So we're going to go opposite on the operation. Add 40. Copy, paste. Copy, paste. Cool, cool. This becomes 63 is equal to, drag it down, 21x. We have to isolate for x here. So we're going to divide because it's the inverse operation for multiply. We get x equals 3. We believe that the point of intersection x value is 3. I love it. Now, what's the y? So I'm going to grab this and drag it down just because it is a hot mess up there. Seriously, a mess. So I'm going to substitute a 3 in for both. I'm going to put it in here, and I'm going to put it in here, and then plug into my calculator and see what my outputs are for y. We're looking for y here. So I'm going to substitute 3 minus 5 times the quantity of 3 minus 4. I get 8. Fingers crossed I get on the bottom one too. So we get 8 times 2 times 3 minus 5, and I get 8, coolio. So we know that the y value is 8. Our point of intersection then, x is 3, y is 8. The point where those two lines would intersect. All right, friends, last problem of the day. Yay! All right, we're looking for the point of intersection again. We're asked to do a bunch of stuff here. So find the point of intersection between two equations. We need to do that with the table, the graph, and the equation again to verify in the real world situation that they are the same. And I'm actually going to undo what I just did, or I'm not going to be able to read the problem. Maria has $325 in her savings. That is sounding like a B value to me. She starts spending, ooh, negative, lines going down if the bank account is, if money's coming out of the bank at $30 per week. That's sounding like a slope to me. Max has 55 in his savings. B adds, that's a positive 15. We're looking for the point of intersection. So when does Maria and Max have the same amount of money at the same amount of time? I think I'm going to go down and do these first because I have all the info right here. So 325. Okay, so 325 is Maria's beginning amount, and Maria's spending, was it 30? I think it was 30. Yeah, it was. So we get the equation of y equals negative 30x, decreasing line, because money's coming out of the bank account with the beginning amount of 325 in the bank account. Boy, that's not going to last. Money's not going to last very long for Maria. Sorry, Maria. And Max, what do we know about Max? Well, Max has, I don't remember. Do you remember 55 at the beginning and adds 15? Okay, so that's fun. Max has 55 at the beginning and adds 15. So the equation for Max then is y equals 15x plus 55. You know what I'm going to do? This is a secret, but I'm going to go find that point of intersection with the equation right away. Why wouldn't we? We know how to do that. Let's set them equal. So we get negative 30x plus 325 is equal to the quantity of 15x plus 55. Cool. Then smallest variable term goes. So we're going to add 30x, copy, paste, copy, paste. We get 325 is equal to 45x plus 55. Subtract 55, copy, paste, copy, paste. So we get 45x is equal to, oh boy, I don't even know what that is. 325, okay, minus 55, okay, is 270. All right, we knew that. So we get 270 equals 45x. Divide both sides by 45, coolio. And so we get x equals, oh boy, 270 divided by 45, was it? Uh-huh, is 6. 6 what? Well, I don't remember. They have it at the same amount of money at 6 something. Well, duh. 6 months? Weeks. Weeks, 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 weeks. At 6 weeks. How much do they have at the same time? We have to use the equations. So Max, or Maria rather, spends $30 per week, starts with 325. So over 6 weeks, each of those weeks she takes out 30, so that's a negative 180 getting taken out of 325. So that is looking like what for Maria? Negative 180 plus 325. Looks like 145 is left. So I think it's going to be 145 when they intersect, but let's see what happens over here. Y equals $15 for Max for 6 weeks. Putting the money in the account starts with 55. Pretty sure this is 90 plus 55. I'm going to send my verify team in, aka the calculator, and verify. Yeah, 145. So that's our Y. So the coordinate really here, when I say this, is really 6 weeks, $145. So this is our weeks, 6 weeks, $145 is the point of intersection. So that means when we graph up here, we should still have I don't like when that happens. We should have 645. At week 6, 145 rather. It should have been 145, not 45. Yeah, 145. I knew that. At 6 weeks, $145. Okay, we should have that happen up here as we go. So let's start. At week 0, at the beginning, Maria has 325. I know that. We know they should intersect at 6 because I kind of cheated my way through that. So I'm going to work my table to the 6th. All right. And each week, Maria takes out $30. So we're going to subtract off 30 here. Would be what? $295. Right? You know what? I'm going to use my calculator. Seriously, you're like, Volkman, you should be able to handle that. But I can't. It's $295. Subtract 30 is $265. Subtract 30 is $235. Subtract 30 is $205. Subtract 30, 205, subtract 30, 175. We are hoping we get to 145. Subtract 30, boom, is 145. Remember, that's what we said down below at week 6. They would each have $145. Look what happened. Now let's hope Max has the same scenario or we are going to have a disaster on our hands to figure out. All right, Max, work with us here, Max. Come on. So at week 0, Max has $55. That's what it says in the problem above, and I can't remember Max's slope. 15, adds 15. So we're going to work to week 6 again because we cheated just slightly because we found it through the equation first, but why not? Let's use algebra in algebra class. Duh. 15 going in each time. Is that what it was again? Oh, yeah, 15. Okay, so add 15. That is so annoying when that happens. I get so frustrated. So we add 15. We add 15 each week. Add 15 is at 100. Add 15, 115. Add 15, 130. Add 15, 145. Yes, at week 6. Maria, Max, same amount of money at the same amount of time. That's called the point of intersection. Y is savings, so we're going to write that on our axes or axis. X is number of weeks. Now, we only have to get to 6, so I'm going to probably skip a line here. Skip a line, whoop, that didn't work out. Skip a line 1, skip a line 2, skip a line 3, skip a line 4, skip a line 5, skip a line 6. We only need to get to 6 weeks. Now, the money in the account is a little different here. We do start at 55, and we got to get all the way to 325. I'm going to erase savings only because I need to be able to write there. Again, if you don't have graph paper at home, you just need to give it your best shot here. But I'm going to start at 0. 50, 100, 150, 200, 250, 300, 3. Can we go by 25s? 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. I think we can go by 25s. So every line is 25. I'm not going to write all the numbers because this stylus is not my favorite thing in the world here. So 0, skip a line, 50, skip a line, 100, skip a line, 150, skip a line, that's 150, see what I mean? 150, skip a line 200, skip a line 250, skip a line 300, skip a line 350. Okay, and so now I'm going to try to color code these in completely different colors so it pops right at us. Okay, so I'm going to use pink for Maria, 0, 325. 1, 295 is a little bit of a guessing game. That's the difference on these kind of graphs, is a little bit of a guessing game, and that is not at 1. That is not at 1. So 1, 295, 2, 265, 3, 235. This is not going so well for me, you guys. 4, 205. 3, oh, that's 325. That's why. I am sorry. So sorry. That was 3, 235. I got to read this better. So that's 225. So 235 is just slightly bigger. 5, 175, that would be a nice one to graph because it's actually at an intersection. And then 6, 145 is not perfecto, but it gives us at least a picture of it. Now, we know that this is Maria's graph. They're both M, I guess. It's a decreasing slope. It starts up here at 325 and the money is coming out of the account. Eventually, it's going to hit 0 unless she refills it. All right, let's try Mr. Max now. So Mr. Max has 55 at the beginning. At month 1 has 70. That's 75, so just below 75. At month 2 has 85, so kind of in between 100. At month 3 has 100, so you can see it's not as steep. Month 4 has 115, so just a little bit greater than 100. Month 5 is 130. Month 6 is 145. So here's Max. You can see that the point of intersection is happening where we said it was going to happen. At month 6, about $145. So kind of that same idea. So that wraps up that page. So that is our learning targets for basically everything in Unit 4 in preparation for the Unit 4 test on point of intersection, really. Y equals mx plus b. Have a glorious night.